Okay. So did you start recording from your side? Can you hear me? Said? Guys, can you hear me?
Yeah, I can.
Excellent. So we will be talking about, by the way, my name is Orhan. I am teaching CCD classes mostly and lots of technology classes as well, service providers, BGP, V6, lots of stuff, and newly IoT, ML, AI, those kind of things will be coming, SD-WAN, SDN, so on and so forth. Today we are talking about BGP in the large scale, hyperscale data centers. With me, I have one of my friends and students. Actually, he deployed BGP in the large-scale data centers, and he will be presenting probably after 10 minutes. First, I will introduce, there is an RFC 7938, recommended many things actually in this RFC, but for our discussion, I will show you ASN Autonomous System Number Allocation Schema recommended by this RFC, and pros and cons of this recommendation actually we will discuss, and after that what Ramiro they did for their deployment, we will discuss about that. So in this RFC, first they are talking actually the how BGP can be adapted into the this kind of data centers. Those data centers, by the way, you can hear as web scale, hyperscale, massively scale, MSDC, massively scale data centers, so on and so forth. And as I just said, there are many things discussed in this RFC. Why not other IGPs? In fact, other IGPs were tried by those companies like OSPF, ISAS because of flooding issue, because lots of actually lack of those requirements. They migrated from the link state protocols to BGP. We know that publicly, lots of documents, lots of videos actually they shared, and we know that. OSPF and ISAS, lack of good open source implementation, lack of traffic engineering control, inbound, outbound, lots of flooding, so chatty protocols, so on and so forth. But then when they deploy BGP in those data centers, people argued BGP, three things especially. BGP is slow protocol. Yes, control plane convergence point of view is BGP is slow. BGP's wide array protocol shouldn't be used in the data center. And also another argument from those guys, I'm just going to that point, BGP neighborship is done manually. For each and every neighbor, you need to basically tell, this is my remote neighbor, this is the AS number, IP address, blah, blah, blah. You need to define that. But actually, these are not so true, or we can do something about them, so we can adapt, we can use BGP in the data centers. Very fast, let me go through them, and then let's see the ASN, Autonomous System Number Allocation Schema recommended by this RFC, as well as alternative way of deploying autonomous system numbers in those data centers we will be talking about. It is mostly true that it's used in the wider network, but we can adapt it. How? Okay. For BGP control plane convergence, I am not talking about data plane convergence, BGP FRR, BGP prefix independent convergence, though it's in the BGP Zero Hero course, but we are not talking that. Control plane convergence point of view, what we can do to make BGP convergence faster. Actually, what are the timers we need to know? We have minimum route advertisement interval timer, we have keep alive and hold timers. So minimum route advertisement interval, when you receive the update from the neighbor, how long you will wait to send this update to another neighbor. Why you are waiting, similar to OSPF, ISA spacing timers, etc. So we might be receiving this same announcement from multiple paths, and we shouldn't send for each and every update new messages to the peers. Pacing timer, very similar, right? Minimum route advertisement interval for the IBGP sessions is 0 seconds. For EBGP, 30 seconds. This RFC mostly recommends EBGP. Why? Because IBGP, when we deploy, lots of things we need to consider, like where you should deploy RR redundancy, route reflector I'm talking about. When there is an RR, where you will put it. Okay, based on the location, you need to deal with the BGP Add Path, shadow RR, etc. to send more than one best path. So, and not only that, but EBGP compared to IBG comes with the much more traffic engineering features. So you can manipulate the path inbound and outbound directions. So EBGP was the recommendation, and deployment also by the authors of the RFC also. But when it is EBGP minimum route advertisement interval is 30 seconds, and this 30 seconds for the data center case might be a problem. Depends. Why depends? In the data center, generally, neighborships physically, switches are connected back to back, right? There is no transport equipment in between. There is no extra device in between. So when there is link failure on one side, another side, or another switch, let's say, we'll see it immediately, and BGP session will be reset immediately. So there is no wait timer there. But still, for the whole timer I just jump into, but minimum route advertisement interval I was talking about. For the minimum route advertisement interval for IBGP session 0, EBGP session 30 seconds. So we should also make it similar to exponential backoff in OSPF and ASAS. We should make for the first time update to 0. This is the first recommendation. Another is keep alive and hold timers. I was just saying, normally this hold timer is 3 minutes for the BGPs, but again we can reduce it to 3 second and 9 second recommendations. Where basically why we would use them to catch software errors. Otherwise, for physical link down events, BGP will immediately sense this, because when link goes down, BGP session will be reset. There is no transport equipment, just I was explaining, in between in the data centers between the switches. They are connected back to back. Okay, fine. BFD also for the failure detection, fast failure detection can be used. BFD's main usage for that is again cable misconnection, one-way cable problems, etc. Other than that, recommended keep alive values and hold timer values, as I show you here, 3 seconds and 9 seconds. Third issue, or third argument, BGP shouldn't be used in these data centers is, okay, manual processing, manual neighbor establishment actually. But that's true that manual establishment was there, but when you think about data centers, thousands, if not tens of thousands of switches we are talking about, so it's better, less configuration overhead if we have for maintaining the neighborship, as well as not only for the data center, but maybe very large scale hub and spoke deployments such as the MVPN, etc. So how we can make it more dynamic. In fact, there are two drafts. One of them is suggesting using LLDP with, so linked layer discovery protocol, standard way of detecting some neighbor parameters between the BGP speaking devices. And this is, we have Cisco proprietary CDP, Cisco Discovery Protocol, and we have standard way of doing that, and we call it LLDP. Using LLDP and BGP together, and basically sending between the BGP neighbors their IP address, remote AS numbers, etc., sharing them, and making basically dynamic BGP neighbor establishment. Another draft basically recommending totally different things for the same purpose. Purpose is what? How we can BGP session dynamically established. Okay, TCP 179 is used, as you might know, for BGP establishment, but how we can make it like OSPF and ISAS again. They are using their hellos are sent to the Multicast group, and if you enable on one interface in OSPF and ISAS, just OSPF enable on this interface, and another side OSPF enabled as well, they discover each other because UDP is used, multicast used, right? Same thing how we can do it with the BGP. Another draft is talking about UDP 179 port number even assigned for that, and this is another idea. So with these two drafts, we can make BGP more dynamic, and in those large-scale data centers, since we have so many devices, we reduce the configuration overhead. Even zero-touch provisioning might be possible after this. Okay, let's move on here, and I will not go through the patenting, but I will mention patenting. Now, let me show you something here. RFC recommends this ASN allocation schema. Sorry, let me not make it very big. This ASN allocation schema, here we have three tiers, not classical three-tier architecture, but we have three tiers here: top of rack, leaf, and spine nodes. In different protocols, you can see these three different tiers as maybe levels, like Rift, for example, routing in FAT3, that protocol says level. In IPv6, when it's used in IoT, we have routing protocol called Ripple, routing over low power, lossy links. So it's called rank. We will call it tier here. So these guys, top of rack, and on top of that leaf, and on top of that spine layer we have. As you can see here in our topology, probably Ramiro will talk about shortcut links, but in our topology, we don't have any shortcut. So between top of racks or between a leaf or between spines, we don't have any direct connectivity. And this RFC 7938 recommendation for those different tiers like top of rack, leaf, and spine is this. So unique AS for each and every top of rack switches. So 64501 here. In this port, I assigned like 19 top of rack switches. So up to that number in this. And another port, we call port or cluster when it comes to top of rack and leaf together. So another is again starting from totally different number. Each and every top of rack in your network will have unique, different autonomous system number. We are using EBGP. We talked about why EBGP versus IBGP. Now, what it says, unique per top of rack. Then, unique autonomous system number within the pod for the leaf layer, but different pod, this leaf, totally different ASN. So, 520, same ASN, same autonomous system number inside the pod for the leaf switches, but different pods, leaf switches have different ASN. And for each and every spine in your network, all share the same ASN. There are a couple reasons for this suggestion. First, why same ASN? I didn't even talk, by the way, today, BGP Zero Hero course, this one. For each and every spine switches, same ASN to but reduce the impact of BGP patenting. So BGP control plane will be converging faster when you assign same AS number on each and every spine. And why unique AS per top of rack? Actually, this will be very obvious when I show you the alternative methods of deploying ASN in the top of rack. But the reason unique AS per top of rack in each and every pod everywhere different, why? We don't have to deal with the allow AS in or AS override, etc. Because think about it, 64501 here, let's say when I want to send the traffic to another pod and to this switch, let's say, and if this switch would start 64501 as well, and 64501 source destination also same AS, in EBGP rule is, if I see my AS number in the AS path, I will reject it. I will not accept it. So two ways to overcome that. Either at this receiving side, you need to do allow AS in, or somewhere in the path, either here, somewhere you need to do what? AS override. We cannot do AS override, we will talk why, but allow AS in, you don't want to deal with allow AS in. So if you do this, okay, unique AS everywhere in the top of rack layer, so we don't have to do any allow AS in, AS override, etc. Now, what we've seen here, 2-byte ASN, by the way, all of them. With the 2-byte ASN, how did I understand? We are limited to 65,536, I think, AS numbers, right? But 65,000 overall total autonomous system number space. For the private space, though, we have much less. Where is it? Next slide. Okay. So with the 2-byte ASN space, private AS range is recommended. In the first place, why private AS range? Okay, we use private AS range in these schemas for two reasons. One, if public AS range would be used somehow, maybe through mistake, etc., those public ASN could be leaked to the outside world, like to maybe to your upstream or through your settlement-free peers. If it would be leaked, we call it route leak. RFC 7908 covers 6 type of route leak, and this one would be one of those dangerous type of route leak, and it would be a problem. Second reason is your upstream, your settlement-free peers, they are using public autonomous system numbers, and now you will be using your even transit operators or your peers AS number in your internal data center. You don't want to have that one as well. So separation. 2-byte and private range was used. If 2-byte is used, 2-byte ASN private range is limited to 1023 AS numbers. If it's limited to 1023, and if we recommend with that RFC, each and every top of rack should have unique AS, different autonomous system number. So we are limited to 1023. In fact, we will have, of course, leaf and spine, so we are limited to 1000 switches only in our network. So that's why we have two options now. Either we will go through the 4-byte ASN allocation schema, so we will have millions of private AS with the 4-byte ASN. Or second approach, maybe we should change this ASN allocation schema, not each and every top of rack to have unique AS, but different things maybe we can do. And then we can still grow, and with the still 2-byte and private AS range space, 1023 total number we have, but maybe we can use 5,000, 10,000 top of rack. Always when you go upper layer, so top of rack will be much more, then leaf will be much less, then spine will be even much less compared to leaf. So this is like when you look at how many people are interested with CCD, then very few, then CCIE, then CCNP, then CCNA, etc. Right? So now what we will do, 4-byte ASN may not be supported by still some hardware, software, okay. 4-byte ASN puts additional protocol complexity. What we can do with the using 2-byte ASN, private range, different ASN allocation schema. I will show this one as well. Then I will give microphone and screen to Ramiro, and he will explain what they did, and we will be talking. I will be maybe asking some questions, then he will be explaining what they have. Here, alternative approach, since we are limited to 1000 total 1023 private AS range, and RFC was recommending that unique AS for each and every TOR, we are basically keeping still the same AS on the spine, each and every spine same AS, because patenting, we want to converge fast, and we are still on the leaf, we are not also changing. Inside the pod, every leaf same ASN, but across the pod, different pods, different clusters, basically different ASNs. But now what we are doing, exactly what we are doing with the here, top of racks, with RFC recommendations, still we are following inside the pod, not everywhere. So inside the pod, unique AS for top of rack, have a look at here. Another pod also, same ASNs. I allocate, let's say for my pods, I have 20 switch, 64, 501, up to 64, 519, 19 switch. I will use those numbers in each and every cluster, each and every pod. Okay, then this schema is okay, but now we need to deal with one issue. This schema solved what? Now I can use With that 1023 ASN, I can use now much more, in total, much more devices in my network. But this LOAS in problem comes into the picture. Why? If traffic comes from here and if the destination here, this packet wouldn't be accepted. Why? Same ASN. Or if you start the traffic from 64502 and destination also 64502, these guys on top of rack switches, you need to deploy LOAS in future and on each and every top of rack switch, because each switch can be source as well as destination. That's the point. Other than that, this ASN allocation schema solved at the spine layer BGP patenting problem, and by assigning different unique ASN for the entire pod top of rack switches and same ASN across other top of rack switches as well, but there is no, as you can see, pod to pod direct top of rack switch connectivity here like this. So it will be IBGP in this case. So there is no cluster 1 top of rack this switch to cluster 2 top of rack another switch. So this would be IBGP. Then we will deal with much more complexity. No, physical topology in this way, close topology we have, and logically we have EBGP, and traffic would follow on this direction. Maybe Ramiro will have shortcuts and etc. We can talk about it. Now it's time for me to finish here. Then I will basically give the microphone and the screen to Ramiro. And he will share his screen and he will be talking about this.
Okay. Okay. If you can see my screen now. Okay, so basically this is a typical CLOS topology that is described in RFC 7938. In a real case scenario, I ended up with something similar. There was some things that were attracting to us in terms of what the RFC discusses, and some others were not. For example, the 4-byte versus 2-byte ASN allocation, which Orhan just described, for us it wasn't a problem because we were not that big to use all 1023 AS numbers. So by day one we went with ASN of 2 bytes only. But one of the things that we were very interesting in terms of the business requirements for this data center was to use the BGP tools or the BGP policies that you can apply, or all the BGP tools that all the tools that BGP gives you to move your traffic, to steer your traffic in the ways you want. That was one of the things that were interesting to us. The other one was using a single routing protocol instead of using two. That simplified things a lot. And in the end, we ended up doing some tests, performance tests, and I think Orhan mentioned it. There is the idea, still the idea that BGP can be only used in the WAN, and BGP can be very slow. Well, I'll tell you that in this particular real network, we had very good performance. We did a failover test after this, and it was everything under second convergence. But let me guys let me explain one of the things that we ended up with, and the things that we tested, and how we ended up doing this is not a pure CLOS topology as described in the RFC 7938, but it's very similar in many aspects. To begin with, for example, we have this topology, which is the CLOS topology. But I don't know, in most of the data centers that I've been, all the servers that we have are dual attached. So I don't see single attached servers anymore. So we ended up with something that has to be somehow meaning this little fella is my server. It looks more like a database, but it is my server for now. And so we ended up having something like this. So we need to have dual attached servers to the network because I don't know, redundancy and even performance. And I'll tell you why performance is the case. So if you do things like that, you have to have a shortcut here. You have to have a connection between the two. So if you do that, you basically end up just pretty much doing that. Oops, sorry. Just moving that AS. Just doing that, yeah. So this is how, after doing some testing, this is how we ended up deploying, which is having all servers dual attached to the network, to the single AS, and will pretty much look like CLOS, but instead of just being one switch, we had two. There is a couple of ways you can do this in terms of how you connect your servers. You can have this having a single layer 3, single VLAN here on both switches, and your servers will be something like NIC bonding, where you have one interface that is active and the other one is passive and just comes in as soon as the primary interface fails. The other thing that you can do in these cases is have MLAG or VPC, which is what we did. We had VPC towards the server, so basically it's 4 channels of 20 gig up to these two switches. So from this point of view, from the rest of the network, this VLAN is advertised by 2 switches. So from the spine perspective, you see that prefix coming in BGP. So say, for example, that is AS65000, and maybe that one is 0001. You see it coming from all these links. So for this to happen, I know maybe simple, but it's also worth mentioning that you have to have your BGP sessions configured with a physical interface, meaning the point-to-point links. That's how you BGP peer, because you don't have a way to discover the next hop. Basically, the next hop is going to be physically connected all the time. That, in my opinion, some people saw it as something that could be avoided, but in my opinion, is something good, because if you peer from the loopbacks, which is in most of the cases what you do, and for example, that link fails, which I'm going to try to maybe put it in. So BGP will reestablish from another, maybe going that link and coming up here. This is something that I think it's in this particular case should be avoided, because that is introducing latency and extra hop without you knowing. In that case, for this particular, if that fails, the BGP session, so we know that we have an outage, and we know that the traffic has to come in another way. So this is how our server access basically is connected. We can have multiples of these. So basically similar to that, having this sort of the topology, and then having ECMP connection. So you have, well, in this particular case, we have 100 gig links between the spines and the leaves. So it's a 400 gigabit per second connection up and down. So that gives you very good capacity. And because of BGP can do ECMP over equal paths, we ended up having a lot of bandwidth here.
Okay, Ramiro.
There is,
Ramiro.
Yep.
Can I interrupt a couple questions, because almost all of your points require some question and clarification, because many people will listen to this. Now, a couple questions let me ask. You said you are basically creating the BGP neighborship by using the this infrastructure link, point-to-point links, right? Not loopback to loopback. And then you gave an example. If I lose, you said this link, then BGP session will be established over the another one, etc. Can you explain what you are trying to say?
Yeah, basically, because if you in a more traditional connectivity, you would have some sort of IGP running between these four switches. So for the time being, let's just focus on these four switches. Well, a more traditional deployment would be is having BGP established between the four switches using loopbacks. But for that to happen, you have to have some sort of another mechanism to find that loopback. Because if you are here and you want to reach the loopback of that switch, you won't have a way to get it unless you have some sort of an IGP or even a static route to connect to the other ports. In that case, which is again more traditional way, if you connect it like that, and then that link fails, your IGP with let's say OSPF will find a way to connect the two loopbacks. So BGP remains up. BGP does not tear down between the two switches. But if you don't have an IGP, which is what RFC 7938 suggests, then you have to have a way to connect these two. And the only way of doing that is by using the point-to-point interfaces in this layer 3 link. Basically, this may be a /30 or a /31, and then you BGP peer with what they call the physical addresses, which is basically using maybe the .1 here and the .2 over there in a /30 or the .0 and .1 in a /31. That's what it means. But in that case, if that link fails, then the physical interfaces where you're peering, they come offline. So the BGP connection will go pretty much down.
An interface, if physically goes down, BGP reset the session immediately, and you are converging to the remaining paths immediately. You are trying to say.
Exactly. That's another good point that you're mentioning. So also, you immediately bring that down.
Also, you said in the beginning that our convergence time we tested, it was like under a second, etc. Right? So did you deploy anything for like BGP FRR, BGP PIC, or did you reduce any timers on the BGP control plane convergence point of view? Anything special?
Yes. Yes, definitely. That helped us. Basically, we use BGP PIC. There's three things that you mentioned in your course and that we use here. One of them is ECMP. Basically, we use these 400 gig links to connect between the different pairs of lists because it's not only one list. So we use ECMP. The second, we use BGP PIC, which is basically a hardware implementation of RFC 7911, which is the BGP additional paths, where all the paths are sent between the switches. You have the only drawback that I've seen it this implemented is your BGP routers use more memory because they have all the paths available in the BGP table. But that means that at some point, for example, from the perspective of this switch, which I'm just going to put it in a different color, from the perspective of that switch, you will have all the BGP connections maybe going out from this fabric. This perspective of what we discussed so far, everything is ECMP, but this is maybe another deviation from the RFC. Imagine that you also have not all your connections are ECMP, but imagine that you have some sort of services coming here, which I assume is more common to real networks, where this is not completely isolated. There has to be some sort of WAN links or connections going to different data centers or something like that. And there, for example, you may go to another region via this WAN link or MAN link or the internet or whatever, or firewalls. And then here you may introduce some sort of metrics. For example, maybe this connection to another region may be preferred over that connection. Then all the way down here, you don't have ECMP anymore, because by policy, you are saying that maybe this connection is preferred over that one. In that case, then what you end up having here is a primary and a secondary. You don't have ECMP anymore. And you want it that way because you want that to be the primary. In that case, you will, in traditional BGP, you will only see one connection going out installed in your forwarding base. And with BGP PIC, we had the option, or we have the benefit of having those two exits from that fabric into our forwarding table. And then the benefits of BGP PIC is that if that exit fails, then you don't need to reconverge at the control plane. Basically, it's a pointer in your forwarding table, which only jumps from being that exit to suddenly being that exit.
Okay.
And in the testing that we did, this converges in under a second. But before you mentioned that, I just want to mention that the third thing that we used to improve performance in this data center, which is BFD. Well, BFD is great. We deploy it almost everywhere because it's protocol independent. It gives you very fast convergence. It's lightweight. In most of the switch architectures is implemented in hardware, so it's not a big deal for the switch to send many packets in under a second. And also in most of modern data centers, I assume there's also other protocols that can benefit from that, such as PIM. We have protocol independent multicast everywhere. So PIM also was subscribed as a client of BFD, so BFD was beneficial for PIM.
Just a second. Now we have many things to again talk individually. Now, first thing, you mentioned about ECMP. I think you are talking about here BGP multipath. Of course, you have multiple links. You want to have multipath, but yes. You said 7911. So, are you talking about BGP Add Path here?
Yes, additional paths. Exactly.
Where exactly do you deploy? Because when it's Add Path, you need to deploy not only on the spine, you need to deploy on the leaf as well. And can you explain? Now, actually, I was trying to realize. Okay, when this multi-home server comes, send the prefixes. Let's say on the spine, you see with these two of this leaf, but then this guy is selecting only one and send to the other guys only one of them. So you need to send both of them. So you enabled Add Path here, and for this guy to understand both of them over the single IBGP.
Yes.
Actually, it is not the IBGP, EBGP. In your case, it was EBGP, right? Between leaf and spine.
Well, this is where it gets a bit more complicated.
Because if it's EBGP, then we wouldn't talk about this. And so what did you do here?
Okay, let me tell you another thing that we tested and also works fine, which is, and I think in the conversation we had before, someone asked, why do you have to have all these pairs or all these switches in a different AS? Which is something we also tested, and this is where additional paths help us. We having the spine in the same AS as the leaf. Basically, in this scenario, we have also our BGP peering, as we say, point-to-point, using the physical interfaces. But in this scenario, we use the same AS in the access switches, which basically looks exactly like this. Let me copy this. Something like this. sorry, also worked for us. In this case, we obviously have, sorry, I'll draw a new one. In this case, we also have a server access. Oops. Anyway, imagine there's a direct link connection here between the two, please.
Okay.
Because it's me crazy. In this case, it also was a successful test where you can have the same AS. The big difference for us is pretty much you have to have some sort of route reflector, because imagine that you have this multiple times in the same kind of sub AS on this fabric.
But this is not the route reflector. Because this spine, it's receiving from EBGP neighbor. This left and the right leaves are in different AS than this 65,000, right?
Correct.
So which means that spine is receiving from EBGP neighbor and advertising to the IBGP neighbor.
Yes.
So then they don't have to be RR.
Yes, so in this case, we have a mixture of the two things that I discussed. In this case, yes, we have EBGP between these, but we can have a pair or pairs of switches, access switches, connecting to servers using IGP. Yeah, and in this case, you need some sort of route reflector. So these guys were providing route reflector services to these switches.
Oh yeah, so for the internal leaves you are talking, they are. But in the first place, why you are placing those two leaves with the same AS with the other spines, not the other leaves? Why you place those two in the same AS, but other basically leaves are in different ASs?
Let me tell you. So both work. Both are options, design options. The benefit of having an AS, a pair of switches in the same AS, first is you have, you can think about it as simplicity because you have everything in a single AS. The reason in our testing, the reason to go this over having the same AS is BGP policy. We ended up with a design where if you have simple server access where you don't need to send traffic other than doing ECMP, you could end up having the same AS for simplicity. You don't need to put it in a new AS. But if you want to enforce some sort of policy, then the tools that EBGP give you are much better. Because, for example, since this is EBGP, you have all the EBGP tools such as AS path prepending and MED and many others across this. But if it's simple as just sending us in the first link as possible to that, then this topology can help you. And in a way, it's simpler, and you have the same AS. Although there is a caveat with regards to route reflectors that we fixed by using RFC 7911.
Yeah, but again, if you wouldn't do in the first place, if you wouldn't place the leaf and spine in the same AS, we wouldn't talk about BGP Add Path, so RFC 7911. So in my opinion, would be even more simpler. This one against the simplicity, I think. So if you would continue everywhere with EBGP, no Add Path requirements here, because when you say Add Path EBGP, why we are dealing with that, I asked. Then you need to change the topology and place the leaf into the. Okay. Now, when you talk about policy, when you say the policy, by the way, are you talking about mice and elephant flow type of separation, or maybe web server over here, the different type of server over different links? What type of policy you are talking for? Path manipulation, AS path prepending, etc.
Yeah, so there's different types of policies that we apply. Most of the policy will come from the WAN, But there is situations, in the WAN, for example, imagine if that is your block that connects you to the WAN. We route by MED, and then that MED can get into here. So for example, if you want that switch to be preferred, then MED, we learn that because we keep everything identical, then all the way to your internal switches, you will take the fastest route to that. We'll never go to this one. But there's other cases where we need to enforce things. For example, we have pairs of switches connect us to external parties like clients and providers through cross connects. In some cases, we need to make that preferred over that one. And in cases like that, we can apply BGP policy here. We can say, I want you to be ASPath prepend, for example, into the network, so that will become primary for that particular link. But then you may have another set of clients which are the other way around. So imagine that now you have another client where that exit is the primary. So you can do it per prefix.
Basically. I got your point. Yeah, per prefix. If you want to send, let's say, over this leaf in that same AS over that leaf, you can do this by even since this is under your administrative control, you can even use MED. You are saying ASPath prepending you can do, etc. Okay, that's obvious for me. What about this BGP PIC? You were explaining BGP PIC. Let me understand exactly how BGP PIC helped in this design. So can you tell me again? Let's speak about BGP PIC here, and how did you cover that?
Okay, so from the perspective of any switch, imagine you have that switch or any of the server access switches, and if you are going from a server access to a server access, and maybe you see a prefix coming from all your from all the uplinks identical, so any path will be the same. But imagine maybe it's easier if I draw it like this. We have one exit here and another exit like that. Then you definitely have, from the perspective of that red switch, you have a preferred exit. Imagine that is preferred over the other one, which I'm going to so imagine that red link is preferred over the black one. Then you need to know here that is preferred. So maybe we apply policy, BGP policy, which that's going to make it preferred and send it across. So for example, ASPath prepend. That one is ASPath prepend, and that one no, it's not. So from the point of view of date switch, now you're not going to have ECMP. You're going to have a primary exit. In traditional BGP, you will only have one exit out.
Just a second.
You're not going to have two.
Let me interrupt here. So I will say something. If I am saying something against your topology, please verify. So guys, what basically he is saying, why he draw those lines on top of spine, not anywhere else? Because this topology, think about this leaves in 6501, okay? Green or red leaf, doesn't matter. Those leaves, let's say for the server subnet behind another cluster, another pod in another AS, these guys basically see those subnet with two next hop, okay? These leaf switches. The next hop will be a spine because we are talking about EBGP, okay? On this left 6501 green leaf switch are seeing for the server subnet spine, two of those spines, and we are using multipathing here. And since we have multipath, so ECMP, equal-cost multipath, we don't need to have PIC, prefix independent convergence. We are using PIC for active standby scenarios, so primary, secondary. So one link, if it's primary, another we keep as hot standby, which means backup secondary link is installed into the RIB, routing and forwarding table, RIB and FIB. So if primary goes down, the secondary is already in the RIB and FIB. So it is just And that's why I think he's also using BFT to detect the next hop failure, so PIC can start working. Otherwise, normally this is back-to-back topology switch layer, so you don't even need BFT. I will come that point if there is any other thing than I described for BFT reason. But so far, why, although he has ECMP, leaf and spines fabric we are talking, why on top of that he will do BGP PIC? You should ask this kind of question. Then he start drawing, not, for example, same amount of bandwidth links. Maybe I will ask why red and black, for example. Probably he will say one link is cheaper, another is expensive. Some reason, maybe one link is more delay, one link is something. So they choose as primary and backup. Why you choose as primary backup? My question. No?
So yeah, this is basically a policy, as you say. In this particular case, we route by latency because this is financial markets. So latency is more important. So you may have a path or a circuit that is preferred because it has lower latency than the other one.
Okay.
As you say, in other cases, could be financial cost, could be bandwidth, many other ways. But this is where you pretty much deviate from the RFC, which the RFC is only like describes a network that is kind of isolated. But this is where you have different. We tested different things, and we ended up with different things because there's the point where you need to exit from that fabric. What I was saying, preferring one over the other, again, in our case is latency, but it could be any other reason, or you may have perhaps this link going across different ASs, and maybe this one goes direct to a separate AS on a different region, or something like that. The case is that you don't have ECMP, you don't have equal cost to this anymore, because by policy, you prefer one over the other. In that case, in traditional BGP with no PIC, from the point of view of this little fella in red, you will have only one best path for that prefix that is coming across the WAN, for example. And this one will not appear in your forwarding table, only on BGP. And if that fails, then BGP has to run again, and maybe you select that as the second exit. But benefits of BGP PIC is that it is implemented in hardware. So when you look at the forwarding table on that switch, you will see that both exits, meaning that exit and that exit, are implemented in the forwarding table, with the only difference that the primary path has an asterisk next to that in the FIB, and that's the pointer. Basically, if that fails, and you know right away by BFT, as Orhan was saying, that fails from that switch, and immediately that pointer points to this exit. So you have a very, very, very fast convergence, to the point that we were doing tests and pings, and you fail that circuit, and you don't lose a single ping. In this particular case, I was testing with Arista switches, and the fastest ping that they can do is about 300 milliseconds. So I didn't lose a single packet with a convergence all the way down to another region and coming back.
In that, two questions. In that failure scenario, you basically shut down that link and then start using another one in 300 milliseconds?
Yes, immediately.
Okay.
So, well, it wasn't detected in 300 milliseconds. I couldn't do more granular than that because I was using traditional pings. Perhaps some sort of traffic generator could have been better, but I was doing the fastest I can do with the single switch, which is pings every 300 milliseconds, so at 3 pings per second.
Another question.
Yeah.
On top of this switch, very fast, spine layer switches, we are not talking about internet prefixes, but your wide area network, right? Prefixes for the wide area network.
Yes.
Okay, not
Correct.
for the internet. We are not running PIC for the internet prefixes here on top of spine.
No, this is a private network basically.
Okay. This data center is connected to their wider network, and the prefix is coming from there, and we are advertising also from DC to the wider network, and PIC, this convergence we are doing for the wider network, internal prefixes, private prefixes, and convergence is important for them because they are doing convergence speed as well as total latency is important finance network we are talking about. And BFT is there. Normally we wouldn't run BFT for this internal defense switch fabric and leaf to detect the spine and so link between the spine and leaf failures. This we don't need BFT for it. BFT to detect the upper so upstream connectivity from the spine. We need to detect that failure to converge to another, or probably even for the spine layer switch itself failure detection, we are using BFT here. Is that correct?
Yeah, that is correct. It's a big argument about using BFT in the point-to-point in links inside the data center. Most people think, as you just said, this is not needed because if someone disconnects that in the data center, both switches will know immediately. Whether in BFT, in the case of WAN circuits or cross connects across the data center, there may be layer 2 devices in the middle where you disconnect and the interface does not come down. So you don't have a way to detect that right away. So BFT is the perfect solution for that. So I think in most of the implementations I've seen is just as you described. BFT is not used for the point-to-point links inside the data center, but only in the indirect connections through the WAN or through providers, external
What about
connectivity.
What about Ramiro? You mentioned you are running PIM as well in this fabric. What's the reason?
Well, PIM it's very common in financial institutions because it's normally used to distribute information such as prices. So, for example, the stock price of something. PIM is common because it's the fastest way of doing it, and then you distribute that across multiple destinations in the fastest way possible. So PIM it's been there for ages. What we normally see it implemented is also, imagine that you have this connection maybe to what we call an exchange, which is basically a trading venue where like London Stock Exchange or maybe New York Stock Exchange, and maybe that's your external entity, and you have some sort of very fast ways to get information from them. Let's just put it in another color. There you go.
If that one is
if that
one is a stock exchange connectivity, I think that 6502 leaf layer would be in the same collocation with that stock exchange, huh?
Exactly. This is collocation. So this may be, for example, the AS, the public AS. Most likely here is going to be a public 5.3 whatever. Yeah. So this will belong to an institution, a financial institution that is doing some sort of business with you, and in that case, if this is a trading venue, what we call a trading venue, which is basically where you can go and participate in the market by buying shares or buying commodities or whatever, they're most likely going to have two ways to connect into your network, and one of them is going to be primary, one of them is going to be secondary. The way normally happens is that you have a feed, a primary feed, which is normally known as feed A, and a secondary link with multicast, which is feed B. And in that case, this is multicast injected into your network. But because this is very critical, what these financial institutions normally do, they inject the same data over feed B. So it's not active-passive, it's active-active. But it's slightly different because maybe the source of that multicast data is different from A to B and the that
So
you
we
distribute
are talking
this
live
inside your
multicast,
net.
right? We are talking
It's
live.
live, but yes, it's a separate feed. So it's imagine the best way to think about it is duplicated data.
Yes,
So
same
that
actually same data, two different paths.
same data.
An application actually just ignore one of them and process one of them, and this also provides for you fast reroute.
Exactly.
Application
exactly.
layer fast reroute.
Yes, because these financial servers, they will be receiving both feed A and feed B. Yeah, and as soon as something happens with feed A, they will immediately switch to feed B. So this is one of the few places where I've seen that the redundancy is built in the application, is not built in the network. So in some situation, maybe here we have a very full meshed topology and we don't have a lot of failures, or we can recover from one or two failures with no problem. But these financial applications, that they will normally switch even faster than what a network can reconverge. So I've seen, this is not going to be the case here, but I've seen in many situations where you don't build redundancy inside the network because there's no point. These applications reconverge in 50 milliseconds or less than that.
So you are saying application layer convergence even faster than what you will do with the multicast only FRR, MO-FRR, or any fast reroute technique here. Okay, yeah, I heard that. Excellent point. Okay.
Or in some cases, for example, this where I'm going to put a different color, and that one, go in completely separate and independent networks that do not have anything to do with them. Physical links, physical switches, physical servers that are completely independent from one each other. And if something breaks on one end, they switch immediately at the application level to the other end. But going back to this scenario, this is another case where we need policy. So if we know that this is feed A, we want to make sure that these links going to this switch are preferred over the other one. So in those cases, you cannot do it with IGP. You have to have EBGP between your spine and your leaf so that you can have BGP tools to allow you to run your policy from whatever all the options that BGP give you to choose one over the other. So yeah, that's another reason why you want to establish policy here, not only for your WAN but also your external connectivity.
Can you tell me about that reason again, please? So was it related to multicast? I was reading some questions from the other guys. So what was that reason for the EBGP you said? Policy reason?
Yeah, because here clearly we have a primary and a secondary, clearly, and that is not as in the WAN. This is because this is feed A and this is feed B, and feed A should be preferred from the application perspective. So you need to make that exit to that destination preferred over that one.
Okay, got your point. So okay, yeah. if you will continue introducing what else you have, you please go ahead. Otherwise, there are some questions also. Guys can start asking, and we can address them as well, and we can wrap it up.
The last thing I would like to say is that we ended up with this as well. That it's not used a lot. So and that's another deviation from the RFC, having these short circuits. All the traffic will go up and down, and almost never will use that. But the reason we ended up having these lanes is because if you have a failure like this one, then you have a single exit out. You have to use that cross-link. But you want to make sure that on your day-to-day operational perspective, you go here and the utilization is close to zero.
Let me tell you something about that. Because I think for the east-west traffic between the data center pods, you are not using that one anyway. But if the from the spine that upstream to the wider network, if that link goes down, when the traffic comes to that failed router, failed link router, it has to go to another side. Otherwise, you will see packet loss. And that's why you want to have that interconnect link between the spine layers. It's used for the wide area, upper layer, not for the east-west traffic. Yes. And I was also, I will talk about this inside 65001. Between the lift switches also you have shortcut direct link. I think it's used for the, you said VPC, so VPC peer link type of connectivity. Yeah. So control plane, yes. You are not also sending in normal situation data from there. Maybe in case of some server failure, you are sending the data through that one. Other than that, you are not also using that access lift switches direct connectivity, right?
That is correct. This link is used to create MLAG, multi-layer aggregation or multi-chassis aggregation towards the servers. I normally tell the engineers that if you go here and see a lot of utilization in these links or in any other links that we have still in the legacy network, that means that something's wrong, either from the design perspective or something that we should avoid having traffic in that. It's only in cases that are specific like that, the WAN exit or MLAG here. But yeah, just to agree with what you just said.
In fact, between the spine switch, that interconnection, that link, you wouldn't need if you wouldn't care the convergence time a lot. So even think about it, remove it. So if that one of those, let's say primary red link fails, the router which is connected to that red link anyway will converge to another router, but it will take some time. So but traffic still coming to that router anyway, and in case of that link failure, for you to redirect the flow immediately from that router to another router, you need to have direct connectivity between them.
Exactly.
Yeah. Otherwise, Ramiro, if you wouldn't have that, you would still learn the spine layers, those wide area prefixes from the another spine through the leaf inside that pod. Actually, you got my point. So you could use your leaf switch in 65000 as transit switch between the routers. Why you didn't do that?
Sorry, say again.
So let's say 65000, right? That AS, you have two leaf switch, green ones. So you put that interconnection between the spines to send, if there is a failure on this upper red link, to send the traffic directly between the spines. So, but if you would remove it, still you can send the traffic between the spine by using the leaf in that 65000, by using the leaf as transit switch. Why you didn't do that?
You can do that. It's not ideal because that's an extra hop. And then we have also situations like this where you may have another data center here on the right talking to another data center on the left. And maybe, not always, but maybe you are the fastest path between the two. So you may be some sort of transit between the two.
He's still thinking always latency, okay?
Yes, always latency. So that could be easily the case. Or even if you have a direct link and imagine that fails for some reason, and you have a fast connection to some region and another fast connection to another one. So this may be kind of your core of the WAN links, which you want to switch or you want to get to another region as fast as possible. So in that case, that link will also be used. In this particular network, we have MED, as I said before, which is something that I have implemented in two of the last places where I've been. And then we just find the fastest path between one region and the other one based on MED, without counting the number of ASs you go inside or something like that. So that we tweak everything so to make sure that MED is the way to go between the different ASs.
MED plus feature. Then we should tell the listener audience of this video to watch our previous video as well. So we made another video, financial network design, and we talked about confederation there. So their wider network also, I think, same company's design. So wider network, sub ASs, confederation, MED feature, MED plus feature, like similar to AIGP. It was working. It was interesting. AIGP, accumulated IGP metric for BGP. So we talked a lot of things there. I think this one also going very well. So nice discussion. So okay, we got that interlinks as well. One of them VPC control plane and in the lift. Another one is basically we could use lifts as transit, but direct bypass link. We are not using lifts as transit, so no capacity usage. Also, you are seeing them as extra hop, adding extra latency, and you want to reduce always the latency in this network, I know. So, okay, anything else?
Yeah, what you say is right. You can easily do this. You can easily have another AS here and use this as a transit. If that's the case, you just want to make sure that you do BGP next hop cell so that you can have this communication. In a situation like this particular one, you don't need that because of the latency thing that you mentioned, but you can have it and it works as well. You don't have a problem. And all this, you get away from using an IGP, just like the RFC say. You can deploy all this with no IGP and no MPLS as well, no tunneling whatsoever. Yeah, I think that's pretty much what I wanted to say.
It was nice. Guys, now a couple questions. Everyone, maybe just one question. Then at least we can finish the recordings after that, and later on we can continue this discussion. All of you are in the CCD group, CCD study group, so we can also continue there. It was nice discussion. You can use your microphone if you want to ask a question. Let's get them an answer and then finish the recording of today.
Yeah, quick question I have. Ramiro, can you hear me okay?
Yeah, I can hear you, mate.
Ramiro, thank you for doing this. And if I heard it right, you said you did all this in Arista, right?
Well, there's a couple of implementations that I've seen similar to this. One of them is using Arista, and others are using Cisco, and others, and in the same place we have some other places where we are transforming into that, and we are not there yet. So both Cisco, Arista, and also cases where Cisco and Arista is deploying the same data center.
So I'm curious if on the leaves for multi-homing, either of them is at this point in time promising EVP and multi-homing, where you don't need a peer link and you do EVP and base multi-homing. So BGP type 4 route takes care of multi-homing and using a DF election and all that. Do they support that today?
Yes, we don't do that a lot because we don't have any requirements of having
BGP on the server.
Going across different regions, and we don't have sometimes the luxury of having any additional processing or tunneling or anything like that. There are cases where I've seen in the past where you ended up with problems and you have to do some sort of overlay, but in this case is not the case. One thing I mentioned and I just remember. Another reason you may need that link is in previous deployments we couldn't convince the server team to have active here. I don't know if they were afraid or what, but we ended up with active passive. And in that case, you have a weird situation here where from the perspective of the spine, you see the VLAN appearing here and up here. But there is no way for the spine to know that that is active and that is passive. So the packets will land equally on this switch and that switch. And when for example, if that is or passive connection, I'm just going to put it in dotted line like that. There is no way for it to know in layer 3 that this is bad, and basically half of the packets come here and half come there, and then you have to use this link. And obviously there is the discussion saying, well, if that's the case, then why don't you make that prefer over this one and make sure that all the traffic comes this way, which is a valid point, but in that case you are underutilizing this bandwidth, and also this is not very deterministic from the server perspective. So you may have your design like this, but at the weekend someone reloads the server and ends up in the other way, which makes it super awful. Making this the primary and then having all the packets doing this set kind of routing up to the uplinks. But yeah, that's another reason you may need this link, even in an active passage, not only on VPC or MLAN.
So you are talking about orphan port situation.
Yes,
when there is a failure.
No, I think it's more than orphan port. I think it's the scenario where LACP is not working on the server side. So I think what he's trying to say is LACP benefit is like the leaf layer knows whether both the links are active or not. I had similar scenario, but in my case, I was using Juniper and I could do EVP and multi-homing without the need for a peer link. So it works without peer link, and the bump traffic only goes to the master. I face some other issues where the Juniper engineering team has assumed that LACP over EVP and multi-homing does not verify system ID. So you can have different servers connected to the other end of a VPC, and the switch will continue to send traffic thinking it's the same device. So there are some drawbacks I saw as well. So I was curious if...
What concerned me here, I'm sorry to interrupt, this is Alvaro. Hamir, by the way, thank you for the presentation and for the questions as well. The only point here that is not clear to me are 2 points, okay? I'm not even talking about touching about a multi-AS versus dual AS or anything like that. But for example, a consideration come to the game when we are talking about, for example, leaf pairs are implemented with MLAG or any kind of other channel technology like VPC or MC lag, doesn't matter. But the point here is a VPC pair of leaves represents a single logical leaf from a redundancy perspective, and requires that both in the pair to be part of the same AS. Okay, this is a point that I understood that you placed them on the same AS. However, we need to ensure that the routes are similarly advertised from the spine to both leaves that share the same AS. And my question was, since that this is not the same vendor, that somehow you had similarly to use any kind of disabled peers as check, and then allow that both leaves in the same AS to receive each other updates once that it is desirable to have this information in sync. Okay. So basically, that's my first question. The second question, it is regarding the interconnection between the spines. I'm trying just to figure out if much more conceptual regarding the CLOS, and also if that interconnection was supported or recommended by the vendor.
Ramiro?
Okay. Yeah, so Going to your second question, the interconnection switches, yeah?
Yeah, between the spine switches, is it recommended or supported by the vendor?
Yes, yes. I mean, we have a very specific requirements sometimes here in financial networks. We spoke with Arista, and Arista specifically, yeah, they are okay with this connectivity. They know that we.
Just to the record, actually, just to make sure that we are on the same page, because I do cover financial institutions, huge ones, card processors and so on. And do you have any letter from them saying that I'm okay with that and I'm gonna support that?
No, not to the point of the letter. They know what they're doing.
What I'm trying to advocate here and play the devil's advocate, it is on the point that the account manager or the pre-sales guy will gonna tell you whatever you want to hear. What I'm asking is much more conceptual, asking, hey, do you have any letter from the vendor saying that I support that implementation on this way?
The answer is no. And then a question to you: do you think, would you see that as a problem in your case, and why so?
Yeah, I do have as an issue because well, one thing it is what it works, and another thing it is what is recommended and supported by the vendor. So when we are talking about financial institutions, they follow some regulations. So if something goes down and the vendor say that I will not support because you are using something that deviates from the recommended or supported by them, then you are in trouble. You know, and that's my own point.
Okay, now in my particular case, we own the design and we are responsible for the design. I don't think in a situation where we ended up with some sort of financial regulation problem, we'll end up blaming the manufacturer.
But you have to agree with me that it will be a business issue if, for example, if you have an issue in your fabric, and then you call the vendor and say, I have that topology. Here is my my HLD, my LLD, and he say, I don't support that configuration.
Okay, no, we haven't had that discussion with the manufacturer, or I mean, they know by having their sales expert with us, and then we discussing what we're doing, but more to the point for them to understand what we're doing, not to have assign a sort of yeah, I support this or I do not support this. They know what we're doing, but we don't have that sort of relationship where we're looking to have some sort of agreement on the overall architecture. I think we will go to them for individual problems, but not as a whole thing. It's something that didn't occur to me, to be honest. But it's good that you mentioned it because you have a different, obviously, perspective from that. But if we had an issue of design, I think it would be down to myself, to be honest. It's me who
that's the point. That's the point.
Okay, Alvaro, one question I said.
I'm being picky here. Don't get it as a personal. I'm being picky here because we all somehow, most of us, a few of us cover financial institutions here, and every time that we do a kind of deviation or customized architecture, we have to have a support letter from the vendor saying, point. Yeah, I do support that kind of implementation. Because, for example, there are some vendors that they do not accept, or they accept with conditions, the one single routing protocol as as an IGP and also to hand over the EVPN stuff. So basically, that's my point. If you had a letter from the vendor saying, yes, I do support your architecture, I certify that, and the answer, if I understood correctly, it is no. What I rely on you, and basically that's it. And if you have somehow most that you are working with leaves with pairs or like any kind of MC lag or VPC, whatever, if you had to disable peer as check, just that.
Okay, guys.
Well,
Just we need to finish. Just one more question. Okay, very fast.
Yeah, it's my turn right now. Great work, great discussion. So, Ramiro, just one question. We're gonna get back to the MLAG configuration and the servers, and I pop up the question exactly on the start of this conversation. You said that the server guys are using the bonding configuration with active passive, but I didn't like the idea of using ACP. And I was about to ask you, what if you had proposed them like using on the leaf sides on the S651 MLAG configuration between the two routers or the two Arista switches, and on their side using also LACP. So you should have configured, this is my proposal, using MLAG on the switches, although they are running BGP, each one of it. And in that specific VLAN where the switch is being tagged or connected, using the VRP in the point-to-point. So basically in the MLAG configuration, the primary instance that is traffic is using equally the both links as an upstream. So that would advantage you in terms of resiliency and redundancy, and also the upper configuration of the bandwidth throughput, because it basically doubles the bandwidth. So
yes.
Considering we're having 10 gigs links on each one of the cables to the server. So this is one question. And the second one, are there any storage technologies being used in this storage? Because this is very important for me, as there are a lot of technologies, distributed storage technologies, which are emerging nowadays in data center. One of them is Ceph, for example. So I'm a bit concerned. I'm a bit interested in knowing how are you passing the storage traffic from one port to the other, or from one rack to the other, more than using IS, because using the BGP and setting different ISs on each different port, because usually the storage traffic, if, for example, it's a distributed system with a large scale, you span more than one rack.
Yeah. Okay. Yeah, I got your two questions. Okay. The first one, I think you refer to BARP. Yeah. We use it. Maybe I didn't specify that to the detail, but basically, people who's not familiar with BARP is basically you have your default gateway living in both switches at the same time, and from the perspective of the switch, it looks more like this. There's no connection here. It exists, but it is not normally used. If the packet lands here, it's forwarded immediately to wherever. Same thing, if the packet lives here, because the server is running LACP, it doesn't know where the packet may end up with. This is just part of that hash. But the packet is forwarded immediately. I think.
Just one quick note about your mentioning. I was referring to AS6501. So for MLAG configuration in Arista, it has the shared link between the two switches. So basically, the switches would be running BGP independent on each one of it. But also on layer 2 domain, there would be cross-connected and configured as a clustered switch.
Yes. It's from the control plane, you have to have some sort of mechanism to understand. From the control plane, looks like this. They need to sync, similar to VPC. You need to have some sort of intelligence sharing between the two boxes. But from the data plane perspective, this is never used. If a packet does into that, it's not like HSRP where it's active passive, or BRRP, which is active passive as well. As the packet comes here, it will forward it immediately to the server. It will never use that cross-link. And I think Cisco used in the past VPC Plus VPC Gateway, which is basically that functionality. If the packet comes here, but the HSRP is here, it will work on its behalf and forward it immediately upwards. In BRP, you don't have an active and passive interface or layer 3 interface. You will have active, and both will be exactly the same. And they will use it, will forward the packet immediately up. That will not be used, although, as you are saying, yes, we need it for control plane and syncing of the state of both, but it will be used immediately up. So effectively, you have 40 gig, these are 100 gig in that case, but imagine there are 10 gig, you have 40 gig output going up. And you have
I'm just concerned about the fact that, for example, regarding the leaves that are in VPC or MC-lag, doesn't matter what kind of other chain technology we are using. It is they have to be seen by the spines as a single logical entity.
Yes.
And based on that, somehow we need, for example, for Juniper and Cisco, we need to disable the peer as a check to allow the both leaves that are on the same IS to receive each other updates, it be in sync, just that, okay? Yeah. And that's my point, actually, I'm not criticizing here. Like I said, it's part of our work to be the devil's advocate.
Yeah.
Anyone else? Only one question. If all the questions finished?
I have one question, sorry.
Go ahead, why?
Just the second question with the storage, he did not.
Okay. Do you have idea on the Alex storage question, Ramiro?
Yeah, I have an answer that you're not gonna like it, which is we have a separate Brocade network for storage. So storage doesn't go across this.
Okay.
It's very flat and it's very boring.
Thank you.
Okay, for the last question, thank you, Ramiro. As I told in the chat, there is a solution in EVPN for port active that only allows the flows through the one link, not the both links. So in AS 65001, that you have a single link between these two leaves with EVPN port active, you can allow only one flow through one link, not both of them. So there is no need for active or any other link between these two leaves. Why don't you choose this solution?
We are exploring more and more EVPN using VXLAN. In some of the implementations that I've seen or I've worked in the past 3 years. But I think it's more something that we are using it to support the requirements where we have the need to stretch something like a VLAN, but not really something like this. In most of the cases, we would avoid any sort of tunneling because of the additional processing and additional latency that we have. Also, with all these servers, guys, all these servers in financial networks and people who work with are physical. You will never see VMs here. You will never see something appearing and disappearing and things like that. All of them are physical. A VM or a chassis is super slow compared to physical servers. And the only reason you may the only case where you may see some sort of chassis with multiple PMs will be for deployment or pre-production, but never for trading, because that's many times lower than a physical link. So in a way, financial networks help that layer 3 segmentation that in other parts of the networking we are missing so much because of the world of virtualization. But here, there's nothing really is going to change because of the speed that we need, that we can have with hardware. So we still have that layer 3 separation, and it's not going anywhere, at least from the perspective of low latency.
Okay.
Orhan, just to thank you, and I promised that the last question, the last one, I promised. Okay, just because something that was not clear to me here is regarding once that we have more than one spine, if somehow you had to change your maximum path support, just that.
Yeah. If you enable maximum path support in these switches, it will, if you don't do anything, you just run the command, it will be 32 spines, which to be honest, if you set it to 2, you set it to 32, effectively is the same thing. It doesn't change from the perspective of the switch itself. You can have multiple spines here if you need bandwidth. Another thing that I've seen in financial institutions, there's normally no need for bandwidth, but for latency. The only bandwidth that you need is to cope with microbursts. And to cope with microbursts, which the financial traffic is very bursty, you will normally require 100 gig links, not 10 gigs, because the burst will saturate that 10 gig link for a few milliseconds and then come down. So it's more latency and microburst allowance that I've seen in networks like this.
Okay.
Thank you so much, Hamir and Orhan.
For the questions, I can still take.
I will continue with the questions on the group. Thank you, guys. Bye.
Thank you. When you say microburst, by the way, I would finish now the session, but just one question. By the way, for those later on who watch this, microburst, very short amount of time, burst is happening. You cannot monitor with this existing tools. There are specific tools to monitor microburst. And even for he said 400 gig links, even for the 400 gig links, it might be a problem, and it might be a requirement to deploy quality of service to avoid microburst. Do you have any quality of service for this reason, microburst avoidance, or just throwing the bandwidth to cope up with this problem?
I think the problem, if you add more bandwidth and you still use 10 gig links, no matter how many 10 gig links you use, if your burst goes 11 gig for a minute, it will be topped by the interface, and you will end up with microburst, which, as you said, is very, very difficult to detect. Normally, you don't know about this, just the bad performance of some applications. So in that case, I think, or 400 gig now would be a way to kind of resolve this. But
so
adding
instead
more
of
horizontal bandwidth, scaling sideways.
There was, I think, voice cut. There was voice count, I think, but so you basically, your way of dealing with that one is not quality of service, but throwing more bandwidth. Is it true?
Yeah, but more capacity per link, not scaling out, which is normally what you would do by adding more spines, which is
overall, not by adding extra spine layers to increase total amount of bandwidth, bisectional bandwidth, yes, they call it, but basically increasing each individual circuit capacity, let's say. I got your point, not quality of service. Okay, guys, thanks.
Correct. Obviously, Yeah. I agree. I agree with what you said. I think you put it well. Obviously, if you grow this, you're also going to need horizontal bandwidth. But again, we suffer a lot from microburst, and that will come down to the individual port capacity, not the horizontal bandwidth per the full fabric, but more on the individual port.
Okay.
Just a quick add-on to your comments here about the microburst. I was studying days ago. I found a website and I put the link on the chat on the window. You should have a look at those links. Basically, they are talking about network implementation for big science networking, big data, and this also applies to your case. There are some good recommendations as well for the server guys. They should be tuning on their side as well the TCP and the buffers, especially if you are talking about microburst on 100 gig strings, and also from the network side.
Okay, cool.
It's very interesting. You should have a look.
I will add that one also into the YouTube channel as well, so people can look. Thanks for the discussions today, guys. For the questions as well. Nice drawings and discussion, Ramiro. So you can follow us from our YouTube channel. You can subscribe, like it, and share it on social media if you like this kind of design talks. We did this a couple times before on the YouTube channel. And if you want more, so you can just like, put a comment, etc. So you can encourage us, so more can come, and hopefully you get also benefits. And bye for now.